Hey, what's up there, Chris?
Hey, Chris.
Hey, how you guys doing?
Doing good.
Great.
Doing good on a Wednesday here. It's been nice down here in San Antonio because we've got some weird cold front situation that got stuck in Texas somehow. I'm not a meteorologist, but it's not even been like it's not even breaking 90 right now, like upper 80s. It's really nice.
Oh, we've been hot up here, over 90 and really high humidity.
Yeah, my dad was telling me it's rough up there in Kentucky right now. Same kind of thing, just super hot, but really humid. So the heat index is kind of outrageous. Well, that's sorry you guys are dealing with the heat, but I think it was last week or maybe the week before that, it was 105 or hotter every day for like 9 days. So
Yeah,
I'm
I
glad
don't
we
think
glad
that
we got a break from that.
I
Yeah.
don't think that I have anything really to complain about when there are people live in Texas on the call. So you might not be bad this week, but
Yeah. Yeah, well that's the same thing. People down here in down south here in San Antonio complain in the wintertime when it's like 39 degrees outside. And I'll message somebody like a friend or something up in Illinois or something like that, and it's -3, or like the Minnesota guys. It's like they're like, yeah, it's not too bad today. How hot is it? They're like, it's only like -12, man. Oh man, that's so cold. All right, 11:01. What do you think, Lisa? Want to
We
give everybody
starting?
some time when we get started?
Mm,
Up to
Let's.
up to you.
I
You
don't
run
know.
the
I'm
show.
gonna. I'm gonna give it another minute or so.
Fine by me.
Yeah.
Fine by me.
Hey, Lucas, Andre, how's it going, guys?
Yeah, Sim showed up down there. Nice.
Hello, hello.
Hey,
Yeah.
morning. Good
Good.
here. How you guys doing?
Doing all
Good.
right. Thanks for tuning in.
I will talk about one of my favorite subjects today, human loop yonder. I've got uh, I've got a
This will
little
be a
bit
good
of
one.
point A, so you can understand point B. We can see how that ties into point C, so I can teach you what I really want to teach about, which is point D. There's a little bit of a lead in here, but I think there's a lot of unknowns. We'll use the common term misinformation about what that is, especially in robotics. I want to clear up some of that.
Okay. All right. You ready, Alex?
I'm
I'm gonna
ready.
go ahead
We
and
want to
get
get
started.
started. We'll go ahead and rock and roll.
Okay. Thanks for joining us for the third installment of our Get a Grip webinar, everybody. Today, we're going to be talking about learn how to achieve 100% quality with Yonder, or just, learning about Yonder, one of Alex's favorite subjects. So we also refer to this as our human in loop software. We're going to talk about how it works, how this impacts the customer's bottom line, and how this differentiates us from our AI vision companies. Really quick, Alex, can you mute yourself, please? Just because I feel like I got an echo.
Oh, okay. Let me click on something over here and do that. If Teams will cooperate.
Thank you. Okay, a few notes before we get started. So if you've been here before, then you'll know that we like for this to be a conversational experience. So please turn on your cameras so we can get to know you. If you have a question, you can raise your hand and we'll call on you to ask your question during the chat, or if we just don't get to it, we can ask it at the end as well. And then also, this is being recorded. So after this, you'll receive an email with the full presentation. And that is it for my intro. I'm not going to hold this up any longer. I'm going to hand it off to Alex, our presenter. And Alex, over to you.
Awesome. Thanks, Lisa. Just keep that back over. Let's jump in. Obviously, just a slide, hanging out, showing a little bit about who we are, what we do, in our size, and that's a portion of our team there in that picture. There's obviously people out on site and things like that. This is my humble beginnings of the webinar. I scrolled across this picture looking for something else, and I was laughing, and I thought this is me giving, maybe a combination of multiple webinars to somebody at a trade show. but my humble beginnings were live and in-person one-on-one webinars. So that's where we got started. And then today's topic, right? Learn how to achieve 100% quality with Yonder. And we'll go into more detail with Yonder, both technically, what we mean by 100% quality, things of that nature, so we're all on the same page. We're going to go and talk about human in the loop, which is, a concept or, a technology. Our version of that in our software is called Yonder, and it's someone over yonder, literally where the name came from. We're going to talk about when you ask for help remotely. When do you need a human in the loop? How a crew chief, which is what that person's called for us, helps what they do remotely to make the system operate again. We'll talk about the benefits, both of human in the loop, kind of other things that come with cloud connectivity. I'm going to pose a question if it actually makes a difference. We'll talk about extra benefits and some other, technical and technology solutions and what that does and beyond just helping with it now. I want to present some issues that systems can't solve remotely, and then we'll recap with hopefully the main bullet points of what we can take away from here to provide value as you look into, exploring robotics and technology for your facilities. But first, we need to take a pause and stop and define some terms. That way, everyone, we're all talking on the same page. So, human in the loop, just broadly speaking, could mean a lot of different things, right? Like in document stuff or in other robotics, it's just a person in the loop of the software. Their systems can be active or passive. Yonder's passive. We'll go into more details on that throughout this webinar. But active systems, kind of in contrast, you could think of like the Da Vinci surgery robot or some type of thing that's teleoperated. So every movement of the machine or the robot is being controlled by a person. It's an active human in the loop, not our system. Ours is passive. Also want to put on the point that our name, Plus One Robotics, is literally because we foundationally believe that it is, a requirement to be successful operationally, to make an impact in operations and be a useful piece of technology. You need a human in the loop. And that's due to that underlined word there, the exceptions. And what we mean when we use that term is anything that the system cannot handle autonomously. I'll go through a few different examples, but there could be countless situations that occur in the real world that the system can't handle autonomously. Either it's not allowed to, or it just can't do it. Those are the exceptions, right? When the thing didn't go down with the happy pathway. It didn't just pick the thing, place the thing, pick the thing, place the thing. Anything that's not that is an exception. Crew chiefs are what we call the person who is the remote supervisor, right? It can be Plus One employees. It can be the customers themselves. They have employees that monitor their fleets and, assist in there, but we call those people crew chiefs because they have a crew of robots that work for them, dozens, simultaneously. And the last point in there is just that, again, we're passive. So this crew chief, this person is called automatically by the system. They don't have to like dial in and check on it. And as problems, it calls them. Now that we've got that straightened out, we'll go into a little bit of how it operates. So you guys can read kind of the steps in there. It's a pretty simple process, right? Something happens in the system's, say, controls architecture or with the vision software that says, hey, I need help. And it just shoots a message out to the cloud, or an on-prem server, and that goes to crew chief automatically. In parallel, we store that image, the data associated with it, the 3D data, as well as the response that the crew chief did to solve whatever problem, which allows us, number one, to take care of the problem now in real time and get the system back into autonomous operation, which is a little faster. But it also allows us to build over time, understand what the problems that we're running into are, the problems that our customers are having when the system's not operating as autonomously as we'd like it to, and we can make changes, whether that be improving AI, which is pretty common practice, or if it's, changing grippers or, modifying, layouts as things scale and progress, because different sites at the same customer have different, processes sometimes. If they deal with different type of packages than another site. So there may be a unique problem on robot 30 that robots 1 through 29 never solved because it wasn't at the site. And I want to specifically, without going all into the research and all that, talk about what human in the loop, what Yonder solves, right? It solves the long tail problem. So if we look at this little graphic I made, you have, this is like a Pareto analysis of problems, right? You have the most common problems. Let's say out of all these, you run into situations, there's 100 of them. Well, 10 of them are happening all the time, whatever it is that you're dealing with, it's happening a lot. So a lot of that is going to be that the AI model is good enough to know what to do. It's going to be that you had a good layout, you have good controls architecture in the programming. Maybe if you're doing induction, you have a conveyor that the robot can reach the whole pick area very well and doesn't approach singularities. You have the right types of cups, you have an adequate vacuum pump, things of that nature. Hardware design, you really want to, work on solving these super common problems so that they're just not issues that has to go to remote supervision. But the other 90 problems, right? Well, they're only happening 1/10 of 1% of the time. All of them together, though, make up 9% uh, issues, right? So you could only ever get 91% efficient, autonomous operation because of all of these different weird problems, ones that you may be aware of, that there's really no solution to, ones that you're unaware of that are just new problems or they come around very infrequently. Like one option here is people are supposed to detrash a pallet before it goes to a decal cell, right? Take off the banding, the shrink wrap, edge guards, things of that nature, things that don't need to get picked. Well, sometimes they show up to the robot and they're not detrashed. Not going to be able to pick up the whole pallet, right? So all of these long tail problems are extremely difficult necessarily to solve, if they're even possible to solve, or they're not cost. The technology that exists to solve them doesn't meet ROI or business requirements or overcomplicate systems. So to solve all of these problems, a person can do it quickly. Pretty easy for people. They're pretty smart at solving problems. So we'll get into more of that. That's that's the point of Yonder, the long tail, the 90, 100, 200 problems that happen extremely infrequently that still happen and still affect the performance in the real world. So when are you going to ask for help? This is a great picture of a situation in which this system's controls architecture and vision, what our software knew about the world and what's supposed to happen in there from, say, the PLC and robot programming side, um, called for help because we saw a pallet, said, yeah, there's a pallet. We also see partial second pallet, but we also see an item to pick. We have a pallet, and an item to pick. And that controls architecture. It says, this situation is very weird, strange. I'm confused. I don't know what I should do about it. So it went and asked for help. And I do know what happened in this situation. The group chief sent them to pick this box. And then we saw two pallets again and again. Hey, you saw two pallets. That's weird. Yeah, go ask for help. And then the group chief said, local intervention, come remove this. This doesn't need to go out to the other pallet stacker because it's going to cause a problem. So that one example, real world, this is real data from a customer site that really happened. These are other two great examples. This one, again, I'm aware of how this went down, but we saw it, we identified it as a slip sheet, but the scoring was like 20%, like a score of 20. Everything had to be higher than I think 94 at this customer. So we weren't allowed to autonomously go pick it. So it said, hey, go ask for help. The group chief drew the boundaries, which you'll see later on, said it's a slip sheet. I went and picked it up, put it in the slip sheet trash pile, saw the empty pallet, moved it out, back to work. And this one on the right is one that needed a local intervention. This is actually a broken pallet. You can actually see the broken slat on the bottom, which got jammed up in the chain and got in a roller. And so even though it was supposed to have left because it was an empty pallet, it couldn't, and it's never going to leave, and the robot can't pick up a pallet at this cell, so needed a local intervention. Need to quit trying to remove the pallet because it couldn't do it. So these are, again, real world examples of where a person can look at this, make the decision extremely quickly and get the robot back into operation versus however long it may sit there until someone, on the floor notices that, it's having a problem. I do want to emphasize too that the point of when to call, when you ask for help, it's application dependent, it's customer and it's process dependent. I bulleted out some points here of just kind of some situations that may exist that want to ask that the system may want to ask for help from a person, but I want to emphasize the point that it's flexible, that our software the way Pick One works, the way that Yonder operates in there is flexible for your process, for what your facility needs in order for, a robotic system, in logistics space to be useful for the teams there on the ground. There could be a ton of different situations that occur, and you can set up your controls architecture of how you want to ask for help. So one of the biggest differences here, noted in the points on here, are that in depalletization, all of our systems that are deployed, which just quite a few, they get one chance to pick. If they go to pick an item, they don't get a vacuum threshold, they're going to turn the gripper off, they're going to move away, they're going to go ask for help because it's extremely risky. You don't want to knock a pallet over, you don't want to, cause that mess. It's a lot of downtime and a lot of effort. So you get one chance. But in most of our induction systems, they get 2, 3, 4, maybe some of them get 5 chances to pick. So like that's the gripper goes down, grabs an item, oh, not vacuum threshold, drop it, go try again, maybe modify that, or tell pick when you missed it and try to get a different pick point. But you may get more options because there's less risk involved there. So it gets just to the point that depending on your process, how you want to lay it out, what works for your facility, it's very flexible on when you actually want to go ask for help versus try some other piece of hard automation, like shuffle a conveyor, for example, on induction. But how do they help when they get that question, right? This one, I spend a lot of time working with our partners and working with our customers on understanding what can be done remotely, right? I think a video is going to do the best job explaining this. Again, our crew chiefs are super awesome, great group of people that allowed me to do screen recordings of them while they're at work. So these are real customers' problems in real time with real crew chiefs answering the requests that come up. And again, I kind of randomized the order and how I spliced this video. But you can see at the top, they have different tools in which they can use, depending on the capabilities of the machine, and depending on what the customer wanted us to have control of or didn't, or the partner wanted to have control of or didn't. So you'll see different tools up there in the top that the crew chiefs can use. And there's various reasons in these situations in which you call for help. Some of these at this customer site here, they have a few robots. There's a photo eye, and if the photo eye is blocked, then it always calls for help. So before we say, hey, before the robot says, hey, I need an item to pick, the first thing the controls architecture asks is that photo eye blocked? If it is, then we just go ask for help. So we don't want to send the robot down off the pick belt autonomously. So again, this is just going to loop back and forth, but this is how they help, right? Tell it where item is, or they identify it as a slip sheet, or they deal with say a riskier situation. This is a great example too of a pallet that's been repaired, right? It was broken. Somebody just threw some 2x4s down and screwed them on it. We see them. It's a different height. It looks weird. It's kind of a package. It's kind of a pallet. Don't know what to do. Well, in 5 seconds, we know what to do. It's an empty pallet, right? Versus just sitting there waiting for someone to show up. And then, of course, we use that to train. So the benefits, which is where I'm leading into here, we'll start with the features, because I think the features are part of a benefit. I think it might be a little hard to tell from that video since it goes pretty quickly, but there's a tremendous amount of tools available to a crew chief. Again, whether that be a +1 crew chief, whether the customer is crew chiefing themselves. There's just a few that I want to point out here specifically. Again, you can read the bullet points, but crew chiefs have controls of the gripper. The gripper has multi-functions on there. The crew chiefs can have control. Maybe they need a single cup. Maybe they need the 3 sections of the cup, or maybe they're going to use the whole gripper, just depending on the size of the item, where it's located, what they think's going to need to be done to solve it. They just click it, they send it. They don't have anything complicated to do. They say, yeah, you know what? I only use 1 cup. This is a tiny item. It's over in a corner, and then they can go click the item. We also have verification. So there's times that we place items, say to go on a sorter, and the AI says, you know what? I think there might be 2 items there. Not 100. I'm not sure enough. I'm 60% sure it's 2 items. It's not enough of a threshold, so we'll just ask, is that a good placement, or should I reject that? Right? Is it good or bad? Or they could give a pick point to go recover, a second item if there was 2, and keep it going. And lastly, one of the real benefits on here is this error You might have seen one in that last video. I know in the video coming up, I have one. They do an error. They say error of the system. So robot's gonna go home. It's gonna flash the red light or the buzzer, and someone's gonna show up and fix it. But they can communicate to the on-site. So when someone does show up to a robot, like that one with the broken pallet, they can error. The pallet is broken. It's stuck. So when someone does show up, they look at the HMI, oh, the pallet's broken and stuck. They already know what to do. They don't have to go figure out why the system didn't, just autonomously work like it had been all day. They already have the information because the crew chiefs get a lot of information that's not available just to a person watching, like the data, from the 3D stuff, the height data, any type of error messaging that Bitcoin wants to send up with them. So there's a level of knowledge of what the problem is that the crew chiefs have access to, that they can communicate directly to the floor in real time. So that's a huge time save for just showing up and helping with an actual problem that needs a local intervention. And of course, if you're connected to the cloud, there's other benefits, right? If you're connected to the cloud so that you can have crew chiefs wherever, right? We have them globally because we have customers that need 24/7 support, run their robots a lot. We have a lot of robots out there. You also get the benefit of real-time analytics, real-time dashboard of how every robot's working, how many picks they got, and drops, their quality, if they're blocked or starved. There's numerous different things that are really tied into the KPIs of the system, or say of the operations. What do they need to know about on a daily basis, on an hourly basis, on a minutes basis, on a seconds basis, about the systems and how they're performing across their entire network. So it doesn't matter if they have facilities in Europe and South America, United States, Asia, throughout the world. You can have it all here at your fingertips. You have the ability to filter it. You have the ability to make your own custom dashboards for specific things that you want to know about. If you have certain issues in your facility that you want to be monitoring, you also have the ability to tie any of these, say you see the color coding there, the red and the orange and the green. You can tie all these back into automatic messaging. So you could have a system that goes in orange, and you can have that message a certain group of people so that they're immediately aware that, hey, the system went to 80% efficient. And that's a threshold that you want to get somebody on right away. Or even red, where it goes even higher, right? And in our systems, some of them that we manage for people, or for our customers, we had it go to our customer service team. That goes up to even like our COO level, right? If stuff gets red, everyone gets alerted when our system is being upgraded. And now my big question, right? Is this the best option? Is there other option? Just purge the whole pick belt every time you can't do anything and you dump 50 items in a reject chute. Is that the best option? No, it's not. Unequivocally, yes. Even in logic is the best option. And I took some time to pull some data from the customers that are, not all of our customers want to talking about all their data. The customers that I pulled it from are a little nicer in that regard. They're happy for us to share them. I won't call out their names on here, but I do want to point out this is real data, right? This is real robots. This isn't me doing a cool machine learning thing in some laboratory on my demos or simulating something out. This is real data, right? Real data of 60 robots, which is reasonably decent portion of our deployment across 5 of our customers. It was an entire year's worth of data output. Our robots worked 33,000 shifts. I think that it's about 250,000 hours work that they did. In that, they picked about 250 million items. Of those 250 million items, about 1.5%, and I'm kind of rounding my numbers here, but it's about 1.5% that asked for Yonder, right? They said, I need some help. I don't know what to do with this situation. And of the amount of times that it asked for help, we solved 92% of those remotely. And you can see down there that average time that the robot was waiting between asking for help, getting an answer, making it back down the internet to the robot solving the problem was 7.5 seconds. Everyone will be aware that there's no bot hinder or human that's standing around watching the robots run that's going to solve a problem in 7.5 seconds. This is tremendously fast. But I do want to be honest, there's still 300,000, right here. There's still 300,000 that couldn't be solved, right? And that could be, various issues. We'll get into that here in a little bit. So there's still some. But if they didn't have Yonder, system had no human intervention remotely, right? And everything that happened on that machine had to be solved in person at the time of the event. Pretty easy to get to $15 million. And I took a kind of an average rolling wage of like $34 per hour, fully burdened, and that's 4 minutes per intervention right there. So with Yonder, those customers spend about $750,000 in wages to handle these problems in person, right? With on-site staff. They didn't do that, and they had to handle all 3.8 million locally. It would have been, I mean, it could easily be more than 50 million, but it's not too far of a stretch to say an average time to fix that problem would have been 4 minutes. That would have been $15 million. So there's significant cost savings just in making the system operate, right? Also up here, 98.5%. It'd be great if that was 99.9, but again, there is so many variables in that long tail. And there's so many types of problems that you see. I think this speaks for itself on, ROI, business case value of having human in the loop, just in the simple fact of making the machine run, keeping the machine running, and keeping operations teams from having to deal with every single problem that it has, right? This average rate here on these 60 systems, which is roughly a 50-50 split between induction and depalletization on the data output, is about 1,000 items per hour rate. So without diving into a bunch of crazy numbers on there, that's not that many minutes between each aspect help across the 60. Right? Huge impact to operations, huge impact to the bottom line, and that's just nothing with all the other benefits that come with Yonder. It's just in the sense of the machine operating. It's not even considering operating cost of how many items were not picked, but you're waiting for someone to show up on site to make the robot, operate here. And there are extra benefits, right? Even beyond that, which I still think is probably one of the greatest benefits that it's just that people don't have to deal with the problems that the robot has. And almost all the problems the robot have, over 90% of them in that case, can just be solved remotely in a few seconds. But there are other benefits, and you're going to see again some of the video here doing it. Yeah, there's a great example of this item summit. It's a piece of trash. They tried to purge it. They tried to pick it. Your chief solved the thing, probably replace it. Like, yeah, I tried to fix it a few times. It's not getting fixed by the robot. So they're able to get somebody over there immediately, give them the message of what the problem is so they can solve it. And I do pose my question down there. If you go to your operations teams and you ask them how this looks, what do they think about someone able to come solve this problem in a couple of seconds versus having to have pull an employee from or a team member from some other job that they're doing that needs to get done that day to go over and help this robot. Ask them if that helps them meet this. And I want to touch the third bullet as well. I think I'm doing okay on time, which is the rules, right? Now, say rules, you can say parameters, controls, architecture, programming, but there's a set of rules and around what you're going to say the robot can do this all by itself, no matter what the situation is. So in decal, it's like the thing exists in the pick area within the reach where the pallet's supposed to be. With induction, right? Same thing. The robot can reach this, it's not in a spot, it's not in dangerous, it's on the pick belt. But the rules for the creature are different, right? Because the assumption is that the situation that did not get handled autonomously might need to do different functions in order to resolve the issue remotely. And people are the intelligence, right? This is not the AI doing something. Here, this is a human being looking at the situation in real time. And this is what needs to be done. So they have a different set of rules. It's not no rules. It's just a different set. I like to point that out. I get asked a lot, well, if a robot couldn't do it automatically, how could a person do it? Well, we're allowed other freedoms as against let the autonomous system have. which is also great for being able to learn and understand as we continue to scale out with customers, make equipment on, lessons learned from, certain layouts for the designs. Our partners appreciate that as much as we. And like all my webinars will end with raining on everyone's parade, there are problems that can't be solved remotely. And some people may think because they use ChatGPT that AI is just tremendously smart and knows everything about all of it and should be able to solve every problem, but just not true. This is an older system. I think it might have been deployed in like 2019 or 2020, but the physical layout there existed in a way that we couldn't just purge and reject stuff, out the ends. Not that you could probably purge a 40-foot tarp out the end anyway, but this system had no ability, right? The robot can't pick that up. It has nowhere to put it. It can't grab it. It's just the back of the gripper. There's just nothing it can do there. This is a situation of which have to call some help for some people to come over here and manage to pull this tarp out and get it done stuff from wherever it's done. But that robot's not going to be able to solve that problem. And I have some bulleted lists there. I won't read them all. I'm sure you guys can, but I can talk about some of these pictures, right? These again, real-time pictures that happened over the last probably 6 months where this image data set from. But we have spilled ice on even. Well, I don't want to put individual. I think this is like Ronald's putty or something. I don't want to pick up these individual little things and put them over there, right? There's a bad box that was busted open on a pallet that people didn't notice when they loaded it. It needs to be cleaned up, and the robot isn't the thing to clean this up, right? It's a decal robot. Same kind of thing down here, right? It got loaded up. There's boxes in the middle of the pallet that literally don't have lids. They're just crates. And this robot's designed to pick up boxes for this customer. And it's just going to pick up individual glass bottles. You're going to have a bad day. Obviously, some of them are self-explanatory. This is a jammed pallet. It was supposed to leave. It didn't. It's jammed up in a weird position. Robot doesn't have a gripper that can pick up pallets. Wouldn't have anywhere to put it anyway. And this one here in the middle is an induction robot. Again, it's like a 20 kilogram, 25 kilogram payload. A lot heavier than that. It's also giant. Doesn't need to go onto the sorter. Shouldn't be there, but it is, right? These are situations where it's just some random shoes. So you never know what's going to come down there, right? There's, hundreds of thousands plus items coming through these facilities every day. You're going to run into these types of issues. And some of these issues need to be resolved, can't be resolved by the machine, right? It doesn't have the physical capabilities to do it. So what was I talking about today? Are there any key points to take away? Again, my sense of humor in here, 1.3 billion items, right? And counting, picking about 2 million a day. They don't pick themselves. But I want to point out that there's about 20 million of those 1.3 billion, rough number, that went to Yonder. And our average right now is about 94 to 96% of those are just solved remotely in less than 10 seconds. Right, so it's a tremendous amount of support to the operations teams, to our customers, whether they're crew chiefing or crew chiefing, of just solving the problem quickly, remotely, not pulling people away from what they're working on currently. Obviously, the definition of human in the loop, which is ours is passive. We talked about that a little bit, but it's just when people are supporting the automation remote, right? There's a person there that gets notified when there's a problem and they're able to support it. Again, this, at scale, which we have, a good amount of robots and a lot of years to be able to set on this number. Our crew chiefs manage between 30 and 45 robots when they're on shift simultaneously across multiple customers and multiple applications. So at scale, this is a really big force multiplier for your labor team, whether you're doing it or if you're having us do it. Being cloud connected has a lot of benefits, both in data capturing, data analysis. We obviously use it. We run it through regression testing for AI model updates, for understanding if newer AI models and architectures that we're working on back here in the lab make big impacts and improvements at your site, as well as just your actual problems at your site, whether that be new SKUs or certain edge cases that exist. that we're able to fully understand because we're able to capture exactly that data, right? The data when it didn't work right. Um, then we do reduce the cost. Human in the loop is at a bottom line money saver, right? Beyond supporting operations, and helping them maintain consistent throughputs and consistent quality, uh, through all their ebbs and flows and ups and downs throughout the year. Um, Beyond that benefit, it's a cost saver. And then again, I tell you, if you're going to bring some robots and you're going to talk to your operations teams about putting some robots in, show them Yonder and ask them what they think, what they prefer. And I think it's back to you, Lisa.
All right. Does anyone have any questions out there? I have one that was submitted earlier, Alex.
Okay.
Does the AI just learn automatically?
So it's a great question. We could go down into a whole bunch of research papers and talk about reinforcement learning and stuff as possible. We do not, plus one robotics, we do not have our AI learn automatically, right? We do have the data captured with Yonder, right? So we do understand the edge cases, the problems, we'll call them problems, right? When the situation just didn't run autonomously, but we want to understand, in further detail of why. So obviously the data will get automatically compiled and then ran through regression testing to understand where the AI was successful and where it failed. But we find in plenty of cases that the AI did a great job, segmented out perfectly, a great pick point. It was classified correctly, and it might be a specific type of item that the grouper is not very compatible with. And maybe that makes us go back to the drawing board with our partner or with our customer, if they were doing self-integration and say there's these new cups or there's this new method or there's this new physical thing that we could do here. Or if it's process related, and we can discuss that with customers, with partners on process and other controls, or if there's other types of sensors and things that could be put in to mitigate issues. So we don't let it learn all on its own. And there's various reasons for that, but the biggest one would be that you don't want to corrupt the knowledge of the AI with some weird edge case that exists that it sees on a frequent enough basis where it starts to change the behavior that you're satisfied with, that is doing a good job because it's starting to learn behaviors, patterns, and understand the world that might kind of work in some situations and start applying that more broadly. We want our AI to be very specifically knowledgeable about exactly how it's supposed to operate in the world and how it's supposed to understand items and what makes something pickable versus not pickable. So we don't let it learn on its own, but the crew chief's responses do influence the learning over time. And we've had quite a bit of studies where we, constantly, are self-critical or, where we're at with it. And we've seen models that were like, say, like 2 or 3 years old, and we'll apply them to, say, some current data that we have. And they may only be able to deal with 50 or 60% of the actual, images and the pic data, where the new model is 98.5, 99%. So, the proof in there is that the human in the loop, understanding those edge cases, the crew chief's responses, and that learning put back in under that control does work. A good question.
Okay. Awesome. Anyone else have any questions out there?
Yeah, Alex, I was wondering what sort of network connection is needed for Yonder to work?
A good question. We have multiple options there. I'll start with kind of the least preferred option, which is 5G network. We do have hardware that's approved through our product team that's designed to work and is compatible with it, where we can run on 5G networks. Um, it's not as good because 5G is not as fast as like hardline internet, but we have that capability. So if there's certain issues in InfoSec or in pilot systems, for example, this is relatively common to use that on the first system. But otherwise, hardline internet connection, it doesn't have to be like a super high speed billion gigabyte Google Fiber. Your standard Cat 5 cable is good, or Cat 6 if it's your standard. It in the infosec world, right, there are always the challenges, especially in today's time with cybercrime and things of that nature that people are concerned with. But in our 250 deployments, we've dealt with a lot of lawyers and a lot of IT departments, and the specific way in which we communicate in like the ports we use, the encryption methodologies, the packet sizes, and the communication protocols hasn't been a blocker for any of our customers yet. But, drop a hard line. There is a little bit of IT work there. Drop a hard line, and we have some support, paperwork and stuff like that, and diagrams. But those are the two options. We have a not connected to your network option, as well as connected to your network, and then the last kind of option in there is we do have the ability to set up a like virtual server on premises, so you could be intranet. Obviously, there's some disadvantages to that, like they don't have remote access. If you have data in that you're stored, there has to be some type of cadence as far as like saving that data, and then either we show up on site and pull it, or send it to us through like an encrypted SharePoint, Dropbox type of thing. So we have multiple options to work with, whatever it is that the customers need. But again, through almost 10 years of doing this now, we haven't had a customer that says, yeah, your stuff's not secure enough. We have a lot of confidence in the way that we've architected it and in the technology that we use to secure the data and encrypt it. It's always a question though, every time.
Awesome. Any other questions, guys? That's a good one. Okay. All right. Awesome. Thanks, Alex. All right. So just a couple announcements. This is letting you know about our next webinar. So it's the last Wednesday of the month, September 25th. Go ahead and mark your calendars. If you want to grab the little bit.ly link, you can go ahead and register for that. And we'll also send you an email so that everybody, if you like this one, we hope to see you back at the next one. So, and please share that with anyone on your team who you think might find this information valuable. All right. And then also the second half of show season is starting back up, right? So these are a couple events that are taking place in September where you can find us. So there's the Parcel Forum in Dallas. I will be at that one. John Albano on our sales team, he'll be there as well. And then we've also got a virtual conference, Robotics Applications Conference, and we've got Dan Grohlman from our development team. He's going to be speaking on AI at that. So I encourage you to look those up, or if you're going to be at either of those, please reach out and let's meet up.
Yeah, you don't miss Dan Grohlman's talk. If you have time to do it, well worth it. Well worth it. I'm not going to spoil what he's going to talk about, but I've seen some of his stuff. There's a lot of really, really cool stuff he's going to be touching on.
Yeah, he's a great speaker. And all right, just know that we appreciate you taking the time to be here and share this time with us so that we could tell you a little bit more about Yonder. If we don't already know you will probably be reaching out to you here in the next couple of days just to see if you have any other questions, if you want to talk a little bit more about automation. And then also we'd love to connect with you on LinkedIn. You can find myself or Alex. And also I encourage you to follow us on YouTube and on LinkedIn. And that is, I believe, all we have today. Again, everyone, enjoy the rest of your day. And Alex, thanks so much for another great presentation.
Not a problem. Thanks everyone for showing up. Appreciate the time. Y'all have a great rest of the week. We'll see you at the next one.
Bye, everyone. Thank you.
Thanks, Alex.